Hello guys, in this video we are discussing about how to find the longest common subarray between the two given arrays. Here given two arrays A and B which contains n and m number of integers respectively. Our task is to find the maximum length of equal subarray, which means the longest common subarray between the two given arrays. For example, consider two arrays A and B which contains these elements. Then we want to find the longest common subarray between these two arrays. For these arrays, we want to get an output 3 because the subarray that is common to both arrays are the array element containing elements 8, 2 and 1 and the length of this subarray is 3. Here I am solving this problem using dynamic programming approach. Whenever we see a recursive solution that has repeated calls for same inputs, we can optimize it using dynamic programming. The idea is to simply store the result of subproblems so that we don't want to recompute them whenever needed later. Let us move to our program. First of all, we are defining two arrays and then calculating the size of these arrays and storing it in n and m variables. After that, we are calling a function for finding the maximum length of subarray. Inside that function, first of all we are creating an auxiliary array DP, and using this code we are initializing all the elements in the DP array with 0. After that, we want to update the DP table in bottom-up approach. Actually, the DP array contains the length of common subarrays from these two arrays, and then we can find the maximum value from the DP array, which will be our maximum value of common subarray. For updating the DP array table, we are traversing in reverse order and checking whether A of I is equal to B of j. If A of I is equal to B of j, DP array will get updated. If A of I is equal to B of j, then DP of ij will be updated as the element at the position DP of I plus 1 j plus 1. For example, this column containing array A elements and this row containing array B elements. This is our DP array. While traversing through each and every element in the A and B arrays with reverse order, first of all, it go to the last element in the array A and compare this last element with all the elements in the array B in reverse order. While comparing these elements, we can find that the fourth element in the array A will be equal to the second element in the array B, which means A of 4 equal to B of 2. Then DP of 4, 2 will get updated as DP of 5, 3 plus 1. That means the element at 4, 3 position of DP array plus 1 will be stored here. There is no column for DP of 5, 3, so here 1 will be stored. Then the loop will go to the next element from the bottom and compare it with all the elements in the array B. While checking, we can see that this element is equal to the first element in the array B, which means A of 3 is equal to B of 1. Then DP of 3, 1 will get updated as DP of 4, 2 plus 1. DP of 4, 2 containing the element 1. Then 1 plus 1 gives 2. This process continues, and through this process we can find the maximum length of common subarray. After updating, we want to find the maximum value from this table. For that, first we are initializing a variable maxim with 0, and for finding the maximum of all values in DP array, we are traversing through this array and checking which element is greater than the others. For finding the maximum value, we are calling a function maxim which compares two values and return the maximum value. Using this function, we are checking each and every element in the DP array and stores the maximum value in maxim variable. And at last, the find max length function returns the maximum length stored in the maxim variable. Using this problem, we can find the maximum length of subarray. Here our input is these two arrays. We can check our output. Yes, it's getting our required output.